question number 16, a quarter cylinder of radius r and refractive index mu is placed on table. Image of a point object O placed at a distance 4r by 3 from point A is found to be at infinity. Refractive index mu of cylinder is. So in the given situation, this is at a distance 4r by 3. So if I apply the formula of the refraction through curved surface, then the formula is mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 upon r. So let the rays incident on the surface from this side, then mu1 is this medium, mu2 is this medium. So I can write for the first time refraction mu divided by v1 minus mu1, that is 1, divided by u, that is minus 4r by 3. Since radius of curvature for the flat surface is infinite, so this part comes to be 0. So on solving, the value of v1 comes out to be minus 4 mu r by 3. Now for the second curved surface, the value of u becomes minus of 4 mu r by 3 plus r. We are talking for the principal rays. So we are applying this formula for the paraxial rays. And so if I apply the formula, then mu2 is 1 upon v2 minus of mu1 is mu divided by u. So the u is minus of 4 mu r by 3 plus r is equal to mu2 minus mu1, that is 1 minus mu divided by r. So with sign convention it can be written as minus r. Since the image is formed at the infinity, so the value of v2 approaches infinity, so this part becomes 0. So if I solve the left equation, then the value of mu comes out to be 3 by 2. So option 1 is the correct answer. Let's move to question number 17. In question number 17, in a compound microscope, the objective and eyepiece have focal length of 1 cm and 5 cm respectively. The last image is formed at infinity. Magnification produced by eyepiece is. So when the image is formed at the infinity, so when the final image is formed at the infinity, then the magnification is given by d by fe in the case of compound microscope. So d is the least distance of distinct vision, so that is 25 centimeter, divided by fe is given in the question 5 centimeter. So the magnification comes out to be 5. So option 1 is the correct answer. Let's move to question number 18. In question number 18, in YDSE of equal slit width, now if one of the slit is made 4 times wider, then what is the intensity at a distance of beta by 4 from the central maximum? So let the intensity from both the slits is I. Then in the first case we can write 4I. So the value of I comes out to be I naught by 4. Now when one of the slit is made 4 times wider, then the intensity through that slit is 4I. So the resultant intensity can be written as I plus 4I plus 2 times under root of I into 4I into cos of phi. Now we have to find out what is the value of phi at a distance of beta by 4 from the central maximum. So phi is equal to 2 pi by lambda into delta x, and the value of delta x can be written as x d by capital D. So d by d into x, so the value of x is beta by 4. So that can be written as lambda capital D by small d, so by 4. So this can be written in this way. So on further solving, it comes out to be lambda by 4. So if I substitute the value of lambda by 4 here, so it comes out to be pi by 2. So this is cos pi by 2. So this part becomes 0. So the resultant intensity is 5 into I, or in terms of I naught, it becomes 5 by 4 I naught. So option 2 is the correct answer. Let's move to question number 19. In question number 19, an inductor L and a resistor R are connected in series with a battery of voltage V. What is the value of current in the circuit at instant when rate of change of energy stored in inductor is maximum. So we have to find out maximum of du by dt. So we have to find out d square u by dt square and put it equal to 0 in order to get the maximum value, in order to get the maxima of du by dt. So in this case, at any time t, the current in the circuit is given by V by R into 1 minus e raised to the power minus R by L into t. Now the energy stored in the inductor at any time t is given by U. So that U is half into L into I square. So if I take the derivative du by dt, then it is L into I into di by dt. Now further differentiate this equation and put it equal to 0. So on doing this, we will get the maximum value of this function when the value of e raised to the power minus R by L into t is equal to half. So if I substitute this value here, it comes out to be V by R into 1 minus half, so that is half. So it comes out to be V by 2R. So option 2 is the correct answer. Let's move to question number 20. In question number 20, a charged particle moves in a straight line with increasing speed v in presence of electric field E and magnetic field B. This is possible when? So two conditions are given. One is the particle must move in a straight line, and the other is that its speed must increase with respect to time. So in order that the speed must increase with respect to time, velocity of the particle must be parallel to the electric field vector, and the particle must move in a straight line. It is only possible when the magnetic field vector is parallel to velocity vector. So if these two conditions are fulfilled simultaneously, then the particle will move in a straight line with increasing speed. So we can see that option 3 is the correct answer. Let's move to question number 21.